Hey there, this is guided practice 1. So these are our guided practice problems from section 2.1, 2.2 on limits. So the first couple, in fact, all of these, we're going to use a table, okay, to find the limit if it exists. We're going to check the graph to confirm. So we're going to do both a table and a graph on each one of these. Okay, so the first thing I'm going to do is I'm going to look at where we're approaching, and that's where x is going, and that's my value that goes in the middle of my chart. That's my x value. Oh, nope. The number on top, that 2 is my x, and the bottom is going to be my f of x, okay? And I want 3 numbers above 2 and 3 numbers below 2. So above 2, I'm going to add a thousandth, add a hundredth, and add a tenth, right? I want you to be that close to 2. On the less side, or the smaller side of 2, we're going to have 1.999, so you're subtracting a thousandth. 1.99 where you're subtracting a tenth, a hundredth, and 1.9 where you're subtracting a tenth. Then we're going to go ahead and plug these into your calculator. So you're going to take your 1.9, store that under your A, and you're plugging into 3A divided by 2A minus 1. And I've got, if I zoom in here so I can write it, I'm going to switch colors for change. Let's see, this is 2.04. If I'm rounding properly. And I'm going to go then and plug in 1.99, and this is 2.004. And when I plug in the next one, it's 2.0004. Okay, so it looks like the limit as x goes to 2 from the left of my function, which is the 3x over 2x minus 1, this turns out to be 2. Right, we're getting closer and closer to 2. From the right, start with your 2.1. Plug that in and you get 1.97. Then go for your next one, your 2.01. That gives you 1.997. And when you plug in 2.001, store that, plug it in, and you get 1.9997. And so as you approach 2 from the right, you're getting closer and closer to 2 as well. So this is the limit as x goes to 2 from the right of your 3x over 2x minus 1. And that's also 2. And that tells you that your limit, because they match, is 3x of 3x over 2x minus 1 is equal to 2. Okay. So that's what we're looking for. We're looking for the 6 values plugged in. We're looking for you to say what the limit values are from the left and the right, and then we can make the conclusion of what the limit is, okay? Now, here's the thing. When you're working on WebAssign, it's likely not going to ask you to write all this out, right? But when we get to the quiz and the test, I'm going to ask you to use proper notation. And when I say proper notation, I mean this part right here. This part right here, and this part right there has to be there every single time. Otherwise, you're not telling me correct mathematical statements, okay? You're making a statement. The limit as you approach this of this function is this value, right? It's making a statement. So you've got to have all of those pieces. So keep that in mind. Now, just to make sure we're right, let's take a quick peek at the graph. So let's go back to our Wolfram Alpha and plug this one in. And it's going to be, what did we say? Which one was on top? The 3, wasn't it? Yeah. Okay. So 3x divided by 2x minus 1. Close the parenthesis and go. And we are approaching 2 from both sides right here. And you can see I'm kind of on it there. But 2 makes sense, right? We got 2. It appears to be 2 from the graph. Okay, so the y value when the x value is 2 is also 2. Okay, let's go to the next one, number 2. Okay, so now you're approaching, this limit is approaching 0 for the x value. So my 0 is going to go in the middle. And I want my 6 values, 3 on each side. So I want 0.001, 0.01, and 0.1, positive and negative. And you're going to plug those in. So you're taking your, I'm going to start from the right. So take your 0.1, store that in your A, and you're plugging that into A plus 1 over A squared minus 3A. Now I'm reading this to you as if I'm entering into a graphing calculator, which I am. If you don't have a graphing calculator, the way you enter may be slightly different, but make sure that you're able to do this and get the same numbers that I'm getting. Otherwise, we should check it out in class and make sure you're putting them in proper order, right? So if your calculator is not this smart, you need to know how to enter it so that you get the right values. All right, for 0.01, I got negative 33.78. And I've got negative 3. Sorry, my pencil's doing something funky. Negative 333.78. Okay. So it appears, and when I'm coming from the right, that we're going to negative infinity, right? Those numbers are getting bigger by an extra place value each time. So it appears as though the limit as x goes to 0 from the right of our function, is going to be negative infinity. So then if we do the same thing, but on the other side, so now we're plugging in the negative version, so negative 0.1, I've got 2.90. Plug in the next one, and I'm getting 32.9. And the last one gives me 332.9. And those numbers are getting larger but positive. So we're headed to positive infinity there. So the limit as x goes to 0 from the right of your function is positive infinity. And because these two give you different values, they're not the same. This tells you that the limit as x goes to 0 of your function does not exist. Usually, again, remember, this indicates an asymptote, particularly when you have one side that goes to positive infinity and one that goes to negative infinity. This indicates an asymptote. So let's take a quick peek at the graph. And this was x plus 1 divided by x squared minus 3x. And let's see, at 0, you can see in both cases, actually it's perfect right here, right? On the left-hand side, you're going up, and on the right-hand side, you're going down. So you're going in opposite directions, and there's that asymptote that we expected, so that it's not approaching a specific value, so the limit doesn't exist. And then our last one, we are looking at a value of -1 is our A value. And we're going to get negative 0.999, negative 0.99, and negative 0.9 on the right. On the left is negative 1.001, negative 1.01, and negative 1.1. And we're plugging those into our function. So you're taking the, I'm going to start from the right, negative 0.9, store that in your A, and you're plugging that into A plus 1 divided by 3A plus 3. And you get 0.3 repeating. Oops, I put that in the wrong spot. Okay, next I'm putting in negative 0.99. And I get the same thing back again. And I see a pattern emerging. I'm getting exactly the same thing every single time. So we're approaching 0.333 from the right. Negative 1.1, let's try that one. And looks like the same thing is happening every single time. Yep, 0.3 here. And 0.3 here. So that means we're approaching 0.333 from both sides. So we would make the statement that the limit as x goes to, we are approaching -1 of your function, is 0.333, which we know, by the way, fraction equivalence is going to be about 1/3. And, oh, this was from the right. And the limit as x goes to -1 from the left was also 0.3, which was 1/3. And so that tells you those two match. And so your limit here as x goes to -1 of your function is going to be that 0.3, or your 1/3, right? And so we want to take a quick peek at the graph and see if we can corroborate that story. So we've got x plus 1, and the bottom is going to be 3x plus 3. And oh, look at that. No matter where we are, and especially if we're approaching -1, we're over here. That graph is 0.33 all the time. And so therefore, it's going to be 0.333. And so that is how we find our limits using charts or by using the graph.